There are 400 billion stars in our Milky Way galaxy. 400 billion. And for every star, astronomers now believe there is at least one planet. Recent data suggests that in our galaxy alone, there are up to 60 billion planets orbiting in the habitable zone of their stars, the perfect distance for liquid water to exist. Our universe is 13.8 billion years old. Our galaxy has been here for almost as long. That is more than enough time for life, even intelligent life, to have emerged not just once, but thousands, perhaps millions of times over. Given these numbers, our night sky should be a cosmic metropolis. It should be ablaze with signals, filled with probes, a bustling network of empires and federations. Instead, we see nothing. We hear nothing. There is only a profound, deafening, and terrifying silence. This is the contradiction at the heart of the Fermi Paradox. In 1950, during a casual lunch, the brilliant physicist Enrico Fermi asked a simple question that has haunted us ever since. But where is everybody? The search for an answer leads us down three main paths. The first is hopeful. The other two are far more disturbing. The first possibility is perhaps the loneliest. We are the first, or we are impossibly rare. This is known as the rare Earth hypothesis. It argues that while simple life might be common, the conditions needed for intelligent life, like us, are the result of an astronomical lottery we happen to win. It's not just about being in the Goldilocks zone. You need the right kind of star. A stable, long-lived one. You need a massive gas giant, like Jupiter, in the outer solar system to act as a cosmic vacuum cleaner, sweeping up civilization-ending asteroids. You need a large moon, like ours, to stabilize your planet's axial tilt, allowing for stable seasons and a predictable climate. Without our moon, Earth would wobble chaotically, experiencing catastrophic swings in temperature. You need a powerful magnetic field to shield the surface from deadly solar radiation. You need plate tectonics, a complex geological engine that regulates the climate through the carbon cycle and forges the continents. The rare Earth hypothesis suggests that the list of requirements is so long, so specific, that Earth isn't just a 1 in a million planet. It might be a 1 in a trillion, or 1 in a quadrillion planet. In this scenario, the great silence is just that. Silence. The universe isn't a metropolis. It's a vast, empty wilderness. And we are the first lonely spark of consciousness to ever ignite within it. It's a lonely thought. We're exploring the most profound questions in science. And if you love diving deep into these cosmic mysteries, make sure you're subscribed to our channel. You don't want to miss what's coming next. But what if we are not the first? What if the wilderness is not empty, but is instead a graveyard? This leads us to the second and most terrifying explanation, the Great Filter. The Great Filter is a theory that suggests on the long path from simple life to a star-faring civilization, there is a wall, an evolutionary barrier, that is almost impossible to overcome. This barrier, this filter, destroys civilizations before they can ever make contact. The terrifying question is not, does the filter exist, but where on the timeline does it sit? There are two scenarios. In the first and more hopeful scenario, the filter is behind us. We have already passed it. Maybe the hard part was the jump from non-life to life, abiogenesis. Maybe it was the leap from a simple prokaryotic cell to a complex eukaryotic cell, a process that took nearly 2 billion years on Earth. If this is the case, we are not just rare, we are the first to have slipped through the evolutionary needle. We have passed the great test, and the galaxy is ours for the taking. But then, there is the second scenario, the one that keeps astronomers awake at night. The filter is ahead of us. This theory implies that the path we are on, the path of technological advancement, is a well-worn track that all advanced civilizations follow, and it always leads to the same place: self-destruction. The silence we hear is the sound of all the civilizations that reached our exact stage of development and failed. What could this filter be? It could be a nuclear war. Once a species discovers the power of the atom, it holds the seeds of its own annihilation. It could be runaway artificial intelligence, an invention that inevitably outsmarts and discards its creators. It could be irreversible climate collapse, a bioweapon that escapes the lab, or a discovery in physics so volatile that it can be weaponized to destroy an entire planet. If this theory is true, then our rapid technological progress is not a sign of our success. It's the sound of our footsteps, running faster and faster towards the same invisible wall that has claimed everyone who came before us. The Great Silence is a warning. Finally, there is a third theory. It is, in many ways, just as terrifying as the filter. What if the sky isn't silent because it's a graveyard? What if it's silent because they are all hiding? This is the dark forest hypothesis, named after the chilling novel by Liu Cixin. This theory assumes the universe is filled with life, but it operates on two simple axioms. 1. The primary goal of any civilization is survival. 2. You can never be certain of another civilization's intentions. Imagine the universe as a dark forest filled with hunters. Every civilization is a hunter, stalking silently through the trees. They are paranoid, and for good reason. If you reveal your location by sending out a radio signal or launching a ship, you are taking a fatal risk. You might encounter a peaceful friend, or you might alert a predator, a civilization far more advanced than you, that sees you as a potential threat to be eliminated. In a dark forest, the only winning move is to stay silent, to hold your breath, to never, ever make a sound. Any civilization that is loud, naive, and reaches out, like we're doing with our radio and television broadcasts, is signing its own death warrant. They are screaming, "Here I am," into a dark forest where the only rule is silence. In this scenario, the Great Silence is not the sound of an empty universe. It's the sound of an audience holding its collective breath, terrified of the hunter that might be listening. They hear our naive signals and think one thing: fools, they won't last long. So where does that leave us? The Fermi Paradox remains one of the most profound and unsettling questions in all of science. It holds up a mirror to humanity, reflecting back our greatest hopes and our deepest fears. Now, I want to hear from you. Which of these theories do you find most convincing? Are we the first? Are we doomed by a great MF filter? Or are we living in a dark forest? Let us know your thoughts in the comments below. The answer, whatever it may be, will define our future. The silence is out there, and we are sending our questions into it. The terrifying part is that we might one day get an answer.